Over the past 25 years, we've had diseases such as Lyme disease, West Nile, bird flu, and SARS go from unknown entities to national stories and magazine covers. Is the animal kingdom to blame? Welcome to ReachMD Book Club. I'm your host, Dr. John Russell, and I'm joined by David Quammen, author of Spillover. So, David, how did you become interested in the topic of zoonotic diseases?
Well, I did a story for National Geographic back in about 2006. They asked me if I would do a piece on a feature story on zoonotic diseases. And I traveled to the Congo, I traveled to Australia. I picked up on some of these sources and some of these stories at that point and did a piece that ran in, I think, 2007 under the title Deadly Contact. But even before that, back in 1999, I was on an assignment for Geographic to walk across the Congo on an expedition, and we walked through Ebola territory. And while we were there, I became acutely aware that Ebola virus was lurking somewhere in that forest, in that jungle, in what they call a reservoir host, the animal in which the virus lives permanently and inconspicuously. And we made sure that our cook never put any dead monkeys into the cook pot. We tried to keep moving and stay about our own business. But ever since that stretch of days walking through Ebola habitat, I've been fascinated by the subject.
So going back, 25, 30 years ago when I was in medical school, I only remember learning about a handful of zoonotic infections, tularemia, brucellosis, psittacosis, and now it seems to be exploding. Every year we seem to have another one that's kind of emerged. Why do you think that's suddenly happening?
Well, it does seem to be exploding, yeah. There's a drumbeat of these things. I mean, the most recent one that's caught attention is something called MERS, Middle Eastern Respiratory Syndrome, which is caused by a virus related to the SARS virus, and it's come out of the Arabian Peninsula. So that's the latest, and people are still watching the various influenzas that come out of Southeast Asia. It seems to be more of a problem now, partly because we're watching more carefully, we're more aware of it, we've got better monitoring and vigilance out in the places where these things first get into humans, but also I think it's absolutely increasing because there are more humans, there's more human contact with animals of all sorts, there's more human disruption of highly diverse ecosystems in Central Africa, Southeast Asia, and elsewhere, and all of those interactions between humans and the rest of the natural world represent opportunities for viruses and others of these pathogens to spill over from their natural reservoir hosts and get into humans. When that happens, then they have the opportunity to spread around the world and infect as many as 7 billion new hosts.
So what percentage of the overall infectious entities that we have in the world are zoonotic?
A couple of different studies have come up with about the same number. Roughly 60% of the infectious diseases known among humans are zoonotic, meaning that they're animal infections that get into humans. So 60% of our known infectious diseases, in the strict sense, are zoonotic, and you could argue that because we're a relatively young species and everything has to come from somewhere, the other 40% ultimately came from other species, from animals, and got into humans thousands of years ago. But in the strict sense, 60%, and that includes a lot of the old notorious killers like bubonic plague and yellow fever, and a lot of these new things like Ebola and MERS and SARS.
Can you talk about the Hendra outbreak in Australia?
The Hendra outbreak, yeah, that began in 1994. It's the very beginning of my book because it's sort of a textbook case of how these things work. Horses, thoroughbred racehorses, started getting desperately sick in stables in a suburb of Brisbane, Australia. The suburb itself was known as Hendra. And these horses were getting feverish and clumsy. Bloody froth was coming out of their nostrils. And 3 men were trying to take care of them, save these horses. A veterinarian, the trainer who ran the stables, and a stable foreman. And as the horses continued getting sicker and sicker and dying, 2 of these 3 men got sick also. One went to the hospital, one went home and suffered through it. The trainer who went to the hospital died, and they isolated from his organs a new virus. They found the same virus in the horses, and that became known as Hendra virus, an absolutely new virus to science that eventually was found to have its reservoir host in giant fruit bats in Australia. And it had fallen out of the fruit bats and gotten onto the grass, presumably under some trees where the fruit bats were eating figs. The horses had grazed up that grass, one of them in particular, and picked up this infection. So it passed from bats to horses into humans.
I mean, bats really seem to be the kind of the common villain in so many of the different stories you tell.
Well, bats are heavily implicated, yes. Although let's don't call them the villain. Let's call them the frequent intermediary. A lot of these new viruses and some of the older ones, when the scientists, the disease detectives, go out and look for their reservoir host, where have these viruses been living, they find that the reservoir hosts in many cases are bats. I mentioned Hendra, Marburg virus in Central Africa, the reservoir host is in bats. Australian bat lyssavirus, Nipah virus in Southeast Asia has its reservoir in bats. This new thing out of Saudi Arabia, MERS, may have its reservoir in bats. SARS, bats. So scientists started asking, why bats? What is it about bats, this pattern? And they came up with a couple of answers. And again, one had to do with sort of statistical artifacts, degrees of detection and searching. The fact that bats are extremely diverse. They account for 1 in 4 species of mammal on planet Earth, means that there are just a lot of different kinds of bats out there. So maybe bats are not overrepresented as reservoir hosts for these new diseases. Maybe they're just overrepresented in the diversity of all mammals. But then there are other factors that suggest that possibly bats are overrepresented. They live in dense colonies, huge aggregations, very intimately elbow to elbow and roosting on top of one another. They live to long individual lifespans. That close interconnectivity over a long period of time seems to be a very hospitable habitat environment for viruses. So that may be part of it too.
Of all the various infections you wrote about, I really found the SARS story to be the most chilling. Can you expound a little bit upon what you learned about the SARS infections?
Yes, SARS came and went in 2003, but the disease experts I've talked to, including some of the top people at the CDC, say, yes, that was the one that really scared them, more so than things that are more notorious like Ebola. A couple of things about SARS were important. One was that it was transmissible by the airborne route. People could sneeze the SARS virus onto one another, just the way we can sneeze a cold virus or an influenza virus from one person to another. So it was highly transmissible through the airborne route. It didn't sicken people until after it had started to be contagious in a given person. So people were walking around. There were walking cases of SARS, and the fact of the airborne transmissibility plus the fact that people who were sick and who were shedding virus were still ambulatory, were able to go to work, to ride the subway, etc., meant that it spread very quickly, got around the world, out of southern China to Hong Kong, from Hong Kong to Toronto, to Beijing, to Bangkok, etc. So it spread very quickly, and yet it was also very lethal. It killed about 1 in 10 of the people that it infected. So it sort of was the worst combination of a virus that was highly infectious and also highly virulent.
And I think on a selfish level, it really killed a lot of healthcare workers.
It did. That's absolutely right, yes. They felt the brunt of it because, particularly in the early stages, nobody really knew how this virus functioned. So a patient in a hospital might typically go into respiratory arrest or have severe, choking, wheezing, problems with breathing, and the healthcare people then would say, let's get a tube down his windpipe. So they were working to intubate him to save his life, and in the course of that, they were exposing themselves directly and massively to the virus that was coming out of the person's lungs.
You're listening to ReachMD Book Club. I'm your host, Dr. John Russell. I'm talking with David Quammen, author of Spillover. So going to another disease entity, Lyme disease, that I think we all have kind of tried to blame on the deer because it's the deer tick. Maybe the deer is not as much of a problem as some other hosts.
That's right, and that's something I learned by spending time with a wonderful ecologist based in suburban New York, a fellow named Rick Ostfeld. And this fellow has been studying Lyme disease for 20, going on 25 years now. He started as a small mammal ecologist, so he did a lot of trapping of white-footed mice and chipmunks and squirrels and foxes, other small mammals in the forest patches of New England, and also studying ticks, collecting ticks that were carrying the Lyme disease bacterium. And after years of studying this, he came up with strong data suggesting, you might even say proving, that the abundance of deer, although these are ticks that prey on deer, suck blood from deer, the abundance of deer is not what determines the risk of Lyme disease. The abundance of the smaller mammals, the mice, the chipmunks, etc., on whom the baby ticks, the larval ticks, do their feeding, that's much more important. So if you have just a few deer and you have lots and lots of mice and lots of baby ticks feeding on those mice and passing the Lyme pathogen among them, then you will have a high danger of Lyme disease in your neighborhood, in your suburb, in your town.
So, David, where do you think the next big one, you use that phrase, the next big one. So what do you think is going to be some of the characteristics of the next big infection that's really going to cause peril to humans?
Well, I asked that question of a lot of the world experts that I talked to. And what I heard from them, people like Dr. Don Burke at the University of Pittsburgh Medical School and dean of the program there, who has studied emerging diseases, and particularly emerging viruses. I asked him and others, what will the next big one look like? And the answers that I got from one expert after another was, first of all, the next big one, the next big pandemic disease threat that hits humans will almost certainly be zoonotic. It will be a new bug coming out of a non-human animal and getting into humans. Almost certainly a virus, and they can be even more specific than that. They say it will most likely be a single-stranded RNA virus as opposed to a DNA virus or a double-stranded RNA virus. There are such things. And the reason for that is that single-stranded RNA viruses have high rates of mutation. They make a lot of mistakes when they replicate themselves, and therefore they have a lot of genetic variation in their huge populations of viruses, and therefore they evolve very quickly. And that makes them highly adaptable, very capable of making a leap from one species of host into a completely different species of host, taking hold in the new host, adapting, thriving, spreading. So what Don Burke and the others have said to me is that we should be watching for single-stranded RNA viruses, and in particular a few families of viruses, including the coronaviruses. That includes the SARS virus and this new virus out of Saudi Arabia, the MERS virus. Those are coronaviruses. The paramyxoviruses and a number of others. For instance, the influenzas. The influenzas have been around forever, but they remain some of the most dangerous viruses, and there is always a new form of influenza coming up. So things like SARS, coronaviruses, things of the within the influenza group, and other single-stranded RNA viruses are the ones that ring the loudest alarm bells among the experts. And that's why the alarm bells for this new MERS virus out of Saudi Arabia rang pretty loudly in 2012.
So what I really loved about your book is you traveled to all these places, kind of Indiana Jones-esque. As a world traveler now, do you feel a little bit different going in a cave somewhere in the Congo? Do you feel a little bit different eating something in some other part of the world that you don't know what the source of the meat is in the stew?
Well, it's funny. The more I learned about these things, the more my irrational fears were replaced by, I guess, rational fears. The more I learned about them from the experts, the more I realized that they're not paranormal, they're not metaphysical, they're not supernatural. They're just physical viruses, and there are limits in what they can do. So if you take precautions, and in my case, the precautions meant standing 3 feet behind the scientific experts and taking whatever physical steps of protection they took, respirator mask, rubber gloves. If you take those kind of precautions and don't make a mistake and you aren't unlucky, then one of these disease experts can work with these things and can help to stop these outbreaks and can control them.
Well, David, thank you so much for being on the program. The book is Spillover from David Quammen.
John, it's been a pleasure. Thank you for your interest.
This is Dr. John Russell. You've been listening to ReachMD Book Club. To download this program or others in this series, please visit ReachMD.com. Thanks again for listening.